Imagine a supercomputer. It is capable of flawless mathematics, right? It possesses an absolutely perfect memory, and it can execute billions of calculations per second.
Yeah, a real powerhouse.
Exactly. But it's locked inside a windowless steel vault. So it can do all this incredible math, but it fundamentally cannot look out the window to tell you if it's raining.
Right, it's totally cut off.
Yep. Today, we have a mission designed specifically for you, the curious learner who really wants to understand the invisible architecture of our digital world. Because it turns out, some of our most brilliant technological breakthroughs are trapped in that exact same vault.
That is honestly the perfect analogy. We build these incredibly sophisticated digital brains like AI models and mathematically perfect ledgers like blockchains, but they are effectively born blind.
Born blind, I like that.
Yeah, I mean, they are static, deterministic systems that just get dropped into a highly dynamic, totally chaotic universe. And bridging that gap is, well, it's the defining engineering challenge of this decade.
It really is. And to unpack how we are actively fixing this, we are synthesizing two really fascinating and seemingly completely unrelated sources today for this deep dive.
Oh, yeah, two very different worlds.
Right. First, a deep dive into computer vision from a plainsight.a blog post about continuous training. And second, a massive December 2025 industry report from Chainlink Labs on powering institutional tokenization.
Which, on the surface, sounds like a weird pairing.
Exactly. Training in AI and moving billions of dollars on a blockchain look like totally different worlds. But today, it's March 25th, 2026, and we are going to explore the invisible plumbing, basically the continuous pipelines being built to connect these brilliant but blind systems to the dynamic reality we actually live in.
It's a fascinating convergence, because whether you are trying to get an AI to, say, recognize a product on a grocery store shelf or a blockchain to instantly settle an international trade, the core problem is exactly the same.
How to feed reality into the machine.
Exactly. How do you safely, reliably, and continuously feed the messy real world into a static digital system?
Okay, let's unpack this with the AI side first. We always hear about AI models achieving like 95 or 99% accuracy in the lab. It sounds like a totally solved problem.
Oh, sure, in a controlled environment.
Right. But the plainsight.ai source introduces this concept called model drift. Let's say you deploy a state-of-the-art camera system in a retail store, tasked with identifying empty shelves for inventory.
A super common use case.
Yeah. And on day one, it works perfectly, 95% accuracy. But then a few months later, the accuracy suddenly tanks to 75%.
Ouch.
Right. And the software didn't break, the hardware didn't malfunction, the store just, I don't know, introduced new product packaging. Or maybe the seasonal lighting changed. Or a janitor bumped the camera angle by 2 degrees.
What's fascinating here is the underlying mechanics of that failure. Because the AI model didn't get dumber, right? It hasn't degraded in its capacity to process information.
So what actually happened?
What has happened is that the underlying data distribution shifted. You have to remember how these computer vision models actually see the world. They don't conceptualize a cereal box the way a human brain does.
They just see math.
Exactly.
Oh.
They are trained on a very specific mathematical representation of pixel values and edge gradients. When the store's lighting shifts from, say, fluorescent summer bulbs to warmer winter lighting, those pixel values completely change.
Wow.
To the AI, it's literally an alien environment.
It's like studying for a highly specific, grueling exam, memorizing every single page. But when you walk into the room, the teacher has swapped out the textbook.
That's exactly it.
You're still a smart student, but your knowledge is suddenly mapped to the wrong reality.
Precisely. In the real world, data is dynamic and incredibly messy. Without constant intervention, a static computer vision system will invariably succumb to this drift.
And that drop from 95 to 75% accuracy isn't just an academic failure, is it?
Oh, not at all. It translates to massive lost operational efficiency, stockouts, and real reputational damage for the businesses relying on these systems. The static model is basically useless without a constant connection to the evolving reality.
So Plainsight's solution to this is a continuous retraining pipeline. They outline this 5-step loop to keep the AI alive and evolving.
Right. The pipeline.
Yeah. First, automated ingestion and filtering at the edge. Second, labeling and curation of that data. Third, the actual model retraining. Fourth, strict validation and deployment. And fifth, real-time monitoring and feedback to start the whole loop over again.
It's brilliant because it transforms a static deployed piece of software into a living, breathing system, one that evolves right alongside the physical world it is observing.
But wait, I have to push back here. Just looking at the logistics of this, isn't retraining a massive vision model constantly insanely expensive?
Oh, it historically has been, yeah.
Like, if I'm a massive grocery chain, you're telling me my cameras have to stream terabytes of 4K video data across hundreds of stores up to the cloud, constantly burning through massive compute costs, just because a brand of cereal changed its box from blue to red.
I mean, that sounds like it would bankrupt the store.
Right.
You are absolutely right to challenge the cost, and for a long time, that was a massive hurdle in the AI industry. Retraining a deep neural network from scratch is incredibly resource-heavy.
So how do they get around it?
Well, the plain sight source highlights how modern pipelines use a hybrid, highly optimized approach. These advanced platforms don't just blindly upload everything and retrain the entire model from scratch every time a pixel changes.
Okay, that makes sense.
They rely on two crucial architectural strategies. First, edge filtering and thresholds.
Meaning the camera itself is making decisions before sending the data.
Exactly. The system monitors its own confidence levels. The edge device, the actual camera in the store, only captures and uploads data when it encounters something it doesn't recognize with high confidence.
Oh, wow. So it ignores the boring stuff.
Right. It filters out the 99% of the day where the shelf looks perfectly normal. It only triggers a retraining cycle when the data drift or the error rate exceeds a specific unacceptable threshold.
That saves a ton of bandwidth.
Huge amounts.
Yeah.
And second, when it does retrain, it uses incremental learning.
Incremental learn. So it's just updating the specific parts of the digital brain that actually need the new information.
Correct. Think of a deep neural network as having multiple layers. The foundational layers recognize basic things like shapes, edges, and depth. The final layers recognize highly specific things, like the logo on the new cereal box.
Got it.
So incremental learning freezes those early fundamental layers so you don't waste compute power relearning what a shelf looks like. It only fine-tunes the final classification layers using the newly ingested anomaly data.
Oh, that's incredibly efficient.
Yeah, by automating this entire pipeline, ingesting only high-impact anomaly data, incrementally retraining specific layers, and automatically redeploying, they restore that retail system's accuracy back to 96% with minimal downtime and a fraction of the compute cost.
Okay, that makes total sense. It turns a fragile, static tool into a resilient, living system.
Yeah.
Now let's pivot, because this need for a pipeline to reality isn't just an AI problem.
Not at all.
It brings us perfectly to the Chainlink Labs report.
Hmm.
If AI models drift because reality changes around them, blockchains have an even more severe foundational condition. They are literally born blind to reality from day one.
They really are. Blockchains are isolated, deterministic networks by design. Every node on the network has to be able to independently verify a transaction using only the data that is already contained within that closed ledger.
Right, the closed loop.
Yeah, and that strict isolation is exactly what makes them so secure. It's why they can process billions of dollars without a centralized intermediary like a clearinghouse. But that exact same isolation is their biggest functional limitation.
They suffer from what the crypto industry calls the Oracle problem. And this goes back to our vault analogy from the start.
The supercomputer in the vault.
Think of a smart contract running on a blockchain as that supercomputer locked in the windowless steel vault. It can execute a self-enforcing contract flawlessly, but it natively cannot look out the window to check external data.
It's totally trapped.
It can't pull up an API to check the price of Apple stock, it can't check the weather data to settle crop insurance, and it can't verify if a traditional bank payment cleared. It is walled off from legacy systems.
If we connect this to the bigger picture, you start to see why this isolation is such a critical bottleneck right now. The December 2025 report notes that tokenization and smart contracts are the absolute killer use case of blockchain technology.
We're talking trillions of dollars here.
Exactly. We are talking about representing anything of value, mutual funds, private equities, real estate, treasury bills, as a programmable digital token on a unified global ledger. But a smart contract is entirely useless for these real-world assets without external data.
Right, because how do you trade a tokenized stock if the smart contract literally has no way of knowing what the stock is trading for in the NASDAQ?
Exactly. You cannot automate the trading of a tokenized asset if the blockchain cannot securely and reliably verify its real-world market price.
That makes sense.
And you can't comply with global financial regulations if the blockchain can't verify a user's real-world identity from a trusted, off-chain database.
Which brings us to the solution, Chainlink.
Mm-hmm.
And the sheer scale of this platform, as outlined in the report, is staggering.
It's massive.
Chainlink has become the industry-standard Oracle platform. They have secured over $100 billion in assets. They've enabled over $27 trillion in transaction value.
Trillion with a T?
Yeah, trillion. And they've published over 18 billion verified messages across more than 70 different blockchains. But here's where I get hung up. How do they actually act as this bridge without just becoming a massive centralized point of failure?
That is the million-dollar question.
Because if one single company or server is feeding the Apple stock price into the blockchain, doesn't that completely defeat the entire purpose of a decentralized, trustless network?
This raises the most important question about blockchain architecture. If your smart contract is decentralized, but your data input is centralized, your entire system is effectively centralized.
Right. So how do they fix it?
Chainlink solves the Oracle problem through Dawn's decentralized Oracle networks. Chainlink isn't a single data feed or a single server.
Right.
Just like a blockchain relies on thousands of independent computers to verify a transaction, a Dawn relies on a decentralized network of independent, highly reliable node operators to fetch off-chain data.
Okay, so multiple independent nodes all go out to the real world, query the price of an asset across 5 or 6 different premium data providers, and bring it back.
Exactly.
But wait, if you have 30 different independent computers all trying to submit their individual price data onto a blockchain like Ethereum every few seconds, wouldn't the transaction fees, the gas costs, be astronomically high?
Unbelievably high, yeah.
It seems totally unscalable for high-frequency finance.
It would be mathematically impossible to scale if they did it that way. And that is exactly why Chainlink developed a protocol called OCR, or off-chain reporting. And the mechanics of this are pretty brilliant.
Let's hear it.
Instead of every node paying a transaction fee to put their data on the blockchain, the independent nodes communicate with each other off-chain over a highly secure peer-to-peer gossip network.
Wait, a gossip network?
Yeah, they rapidly share their data observations with each other off-chain, just gossiping back and forth. They aggregate all these different data points, filter out any outliers or malicious nodes, and then they form what is called a cryptographic consensus.
Oh.
They all sign off on a single, mathematically verified report. Once that consensus is reached, only one node is randomly selected to submit that single verified report onto the blockchain, paying just one single transaction fee.
Oh, that's incredibly smart.
Yeah, it maintains the absolute security and fault tolerance of decentralization, but it operates with incredible efficiency and scalability.
Well, here's where it gets really interesting. Chainlink started out primarily delivering this kind of price data for decentralized finance, or DeFi. But the 2025 report makes it incredibly clear that they are evolving into something much, much bigger.
Oh, totally.
They are actively becoming the TCP/IP and the JRE, the Java runtime environment for blockchains. They are building the universal foundational plumbing for the global economy.
The comparison to TCP/IP is incredibly apt. Think about the early internet in the 1980s and 90s.
Right, before the web we know today.
Yeah, it wasn't a single web. It was just a bunch of isolated, fragmented intranets, military networks, university networks, corporate networks, and they literally could not speak to each other.
They were just islands.
Exactly.
Yeah.
TCP/IP became the standard routing protocol that connected all those isolated islands into the single unified web we use today. Blockchains today are exactly like those early intranets.
Very fragmented.
Highly fragmented. You have Ethereum, Solana, private bank chains. Chainlink is providing the universal standard to connect them all to each other, and crucially, to connect them to the existing global financial system.
And the stakes for building this connectivity are massive. I mean, the World Economic Forum projects a $16 trillion tokenized asset opportunity by the year 2030.
That's just a staggering amount of capital.
Trillions of dollars of traditional financial assets moving onto blockchains. But the report outlines a series of massive hurdles that institutional banks face to actually capture that value. It's not just about fetching a price feed anymore.
No, the requirements for global capital markets are immensely complex.
Right. So let's walk through how this plumbing actually solves these hurdles. Take privacy, for example.
Okay.
If I am a major global bank managing billions of dollars, I absolutely cannot broadcast my clients' proprietary trading strategies or personal data on a public, transparent ledger for all my competitors to see. How does the pipeline solve that?
That is where Chainlink developed confidential compute. It allows institutions to utilize public blockchains while keeping their data completely hidden.
Wait, how does that work on a public ledger?
Mechanically, it uses advanced cryptography and trusted execution environments, often referred to as secure enclaves. It allows the decentralized Oracle network to perform calculations on encrypted data.
So it never decrypts it for the public.
Right. So the network can cryptographically prove to the blockchain that a transaction is valid without ever actually revealing the underlying data to the public ledger.
It's like playing poker, where a mathematical referee can verify exactly who won the hand without anyone ever having to show their cards to the audience.
That is a brilliant way to conceptualize it. It provides the transparency of a blockchain with the privacy required by Wall Street.
Okay, what about compliance? Because regulated institutions can't just transact with anonymous wallets. They have strict anti-money laundering laws.
For that, Chainlink introduced ACE, the Automated Compliance Engine, and CCID. This essentially allows banks to embed KYC, know your customer and identity rules, directly into the tokenized asset itself.
Oh, so the token itself is smart.
Exactly. The Oracle network continuously verifies off-chain identity databases, ensuring that a tokenized security can only be transferred to a wallet that has been legally whitelisted.
Wow. And what if I'm a global messaging network like Swift dealing with like 11,500 banks,
Yeah.
and I need these compliant assets to actually move across different blockchains?
That requires interoperability.
Yeah.
Chainlink built CCIP, the cross-chain interoperability protocol. It securely moves data and actual tokenized value across any public or private chain.
So no infinite money glitches.
No glitches. It uses a highly secure lock-and-mint or burn-and-mint mechanism overseen by those decentralized Oracle networks, ensuring an asset isn't infinitely duplicated when it crosses from a private bank chain onto a public network like Ethereum.
Got it. And finally, the actual settlement, the capital markets functionality. The report mentions DTA and DVP. What do these actually do for a bank?
So DTA stands for Digital Transfer Agent. It is a standard designed to handle the complex multi-step workflows of fund subscriptions and redemptions entirely on-chain.
And DVP.
DVP delivery versus payment is basically the holy grail of financial settlement. It guarantees atomic settlement.
Meaning everything happens at the exact same millisecond.
Exactly. If I am buying a tokenized bond from you, DVP ensures that the exact moment my digital cash hits your wallet, your digital bond hits mine.
So no one gets left holding the bag.
Right, neither party can get front run. The Oracle network synchronizes the payment systems with the blockchain ledgers to ensure the trade settles instantly and immutably, removing the need for a middleman to hold the assets for 2 days while the paperwork clears.
Okay, so we have confidential compute, ACE, CCIP, DTA, DVP, OCR. I mean, that is an absolute alphabet soup of acronyms.
That's a lot to keep track of.
Right. If I'm a developer at JP Morgan, I do not want to stitch together 7 different cryptographic microservices just to launch a tokenized fund. It sounds like a total nightmare to manage.
And that is exactly the most critical innovation in the December 2025 report. Having all these individual tools is great, but it is way too complex for an enterprise to stitch together point by point. So Chainlink introduced the CRE, the Chainlink Runtime Environment.
Oh, this is the JRE comparison you mentioned earlier.
Precisely. Think of the CRE as the ultimate orchestration layer. It allows developers to seamlessly compose all these different decentralized microservices, the data feeds, the privacy enclaves, the cross-chain messaging into a single, unified, automated workflow.
So it hides all the complexity.
Exactly. The developer just writes the logic they want, and the CRE handles all the complex cryptographic plumbing in the background. It is the engine that synchronizes the decentralized blockchain world with legacy enterprise banking systems.
Think about what this means for you, the listener, and the future Internet of Value. It's just like sending an email today, right?
Right.
When you send an email, you don't need to know how the TCP/IP protocol routes data packets through fiber optic cables across the bottom of the ocean.
Nope. You just type it out.
You just hit send, and it arrives instantly. In the very near future, you won't need to know how the Chainlink runtime environment orchestrates decentralized Oracle networks or utilizes confidential compute.
Exactly.
But it will be the secure, invisible pipeline making your digital asset transactions. Whether you're buying a tokenized fraction of commercial real estate or settling a cross-border payment instant, perfectly compliant and incredibly cheap.
It is the plumbing making the magic happen. And what is most exciting is that this isn't just theoretical white paper stuff anymore,
Yeah.
It is actively happening right now in high finance.
Yes, the report has some incredible case studies of this real-world convergence. Yeah. Look at DeFi giants like AE and Lido.
Huge players.
Yeah. They are relying on Chainlink for reliable price feeds. They're using CCIP for cross-chain token transfers. And they're utilizing proof of reserve to cryptographically prove to their users that their bridged assets are fully backed by real reserves off-chain.
And it extends far beyond native crypto companies into the heart of traditional Wall Street. Look at UBS, a global wealth manager with over $6 trillion in assets.
Massive.
Massive. They recently completed the first in-production, end-to-end tokenized fund workflow entirely on-chain. They handled complex fund subscriptions and redemptions using the exact Chainlink digital transfer agent standard we just discussed.
And then there are the massive institutional network examples. SWIFT, the messaging network that connects over 11,500 banks globally, successfully used CCIP to connect its existing traditional infrastructure directly to blockchains.
Which is huge for adoption.
Oh, totally. They didn't have to rebuild their entire banking backend. They just plugged into the pipeline. And Connexes by JP Morgan executed a landmark cross-chain delivery versus payment transaction.
DVP we talked about.
Right. They seamlessly settled a trade with Ondo Finance's tokenized U.S. Treasuries fund across completely different blockchain environments. They are literally wiring the old fragmented world of finance directly into the new world of programmable blockchains.
When you look at these massive financial case studies alongside our earlier discussion about Plainsight.ai and computer vision, a profound thematic connection really emerges.
How so?
Well, Plainsight's continuous retraining pipeline is absolutely necessary for an AI model to be trusted to monitor a retail store. If it can't safely adapt to a changing reality, it is useless.
Right, the drift.
Exactly. Similarly, Chainlink's continuous data, compliance, and interoperability pipelines are the absolute prerequisite for global banks to trust blockchains.
They both need that connection.
Exactly. In both cases, the raw isolated technology is brilliant. But actual utility and institutional trust are only created by building secure, mathematically verified, continuous connections to reality.
It all comes down to fighting the drift and curing the blindness. Whether it's a computer vision model trying to recognize a new cardboard cereal box on a shelf, or a deterministic smart contract trying to instantly settle a cross-border tokenized fund, static technology fundamentally needs a dynamic, highly scalable bridge to the real world.
Because it's the only way they survive.
Exactly.
Yeah.
That is the only way these isolated systems survive and scale.
And that leaves us with a fascinating final thought to ponder. We've spent this entire deep dive talking about AI needing constant real-world data to fight drift, and blockchains needing decentralized oracle networks to fetch that real-world data securely. But what happens when these two isolated systems fully converge?
Oh, wow. I see where you're going with this.
Imagine a near future where a continuously evolving AI model doesn't just recognize a product on a shelf, but actually becomes the oracle node itself for a smart contract.
They really?
Yeah. How do we build a pipeline that guarantees an AI's autonomous interpretation of a messy, unpredictable real-world event is reliable enough to instantly, irreversibly settle a billion-dollar tokenized trade on a blockchain? The plumbing we discussed today is just the foundational layer for an entirely new paradigm of autonomous, interconnected systems.
That is an incredible thought to end on. Because once that supercomputer in the windowless steel vault can finally see out the window,
It changes everything.
it really does. It's going to start making its own decisions about what to do with the weather. Thank you for joining us on this deep dive. Keep questioning how the physical and digital worlds are being wired together behind the scenes, and we will catch you next time.
Space is limited, paper's not. Big energy in it.